We're going to start today by discussing multiplying and dividing scientific notation. It's a lot different than what we did with addition and subtraction with scientific notation, so we're going to see what the difference is today. We're going to start by talking about the speed of light. Light actually travels at 3 times 10 to the 8th meters per second. That's 300 million meters per second. I want to find out how far it's traveled after 5 seconds. After 5 seconds, it's traveled 5 of those 3 times 10 to the 8th meter distances. When I multiply scientific notation to a number, remember that this is all multiplication. I'm actually going to take the parentheses away. Now, I don't have to take the parentheses away, and I think that in your previous classes you may have discussed what happens with associative property. Associative property actually lets me move parentheses. Instead of being around the 3 times the 10 to the 8th, I can move it, thanks to the associative property, around the 5 times 3 instead. This can only be done when it's all multiplication. When I multiply the 5 times 3, it gives me 15. So now I have 15 times 10 to the 8th meters. I need you to go back and recall, is this number in proper scientific notation? The answer is no. This is equivalent to 1,500,000,000 meters. If I move my decimal point 1 to the left, which will give me a number of 1.5, moving a decimal point to the left adds 1 to my exponent. So now 15 times 10 to the 8th becomes 1.5 times 10 to the 9th meters. Pause the video if you need more time to look at this example. Our next example is going to be when we multiply two numbers that are both in scientific notation. So I have the example 6 times 10 to the 4th power times 5 times 10 to the 3rd. Again, this is only multiplication. And in something that is strictly multiplication, there's no addition, no subtraction, no division. Order doesn't matter. So I'm going to rewrite my equation so that I have no parentheses and all multiplication. Since in multiplication we also have something called the commutative property that tells me that order doesn't matter. So for instance, 3 times 4 is the same as 4 times 3. Same thing applies here. I can move the order of my numbers so that I have my coefficients together and I have my powers together. Now I can multiply my two single-digit numbers, 6 times 5, and I can multiply my powers of 10. When I multiply 6 times 5, that's going to give me 30. When we multiply powers of 10, we can simply take these 4 tens that are being multiplied together. I have 3 more tens that are being multiplied together, and it gives me a total of 7 tens. So I have 30 times 10 to the 7th power. Now this is not in scientific notation, or at least not in proper scientific notation, so I do have one more step. In a whole number, the decimal is after the number. I need to move that one place to the left, which adds 1 to my exponent. So my proper scientific notation needs to be 3, or 3.0, times 10 to the 8th power. Pause the video if you need time to write down this example. This screen is just a reminder of what happens when our answer is not in appropriate scientific notation form. Keep in mind that when you move your decimal to the left, you're adding 1 to your power. When you move the decimal to the right, you're subtracting 1 from the power. That's how we get 30 times 10 to the 7th to become 3 times 10 to the 8th. Let's try another example. Here I've got 4.2 times 10 to the 8th times 2.7 times 10 to the 11th power. I'm going to take the time to rearrange my numbers. So I can rearrange, because this is all multiplication, I can rearrange this so that I have 4.2 times 2.7, so that I'm multiplying my two coefficients, and I can multiply 10 to the 8th to 10 to the 11th. Multiplying 4.2 to 2.7 gives me 11.34. Multiplying 10 to the 8th to 10 to the 11th gives me 10 to the 19th power. Now I have an answer. It's not in appropriate scientific notation form though, so we do have to adjust just a little bit. I'm going to need to move my decimal to the left, and I get 1.134 times 10 to the 20th power, since moving my decimal to the left adds to my exponent. One more time, only this time with negative exponents. I'm going to rearrange my numbers so that I know I need to multiply 1.4 to 3, my two coefficients. And I need to multiply 10 to the negative 12th power to 10 to the negative 5th power. 1.4 times 3 gives me 4.2. 10 to the negative 12th times 10 to the negative 5th, again, they've got the same base, so all I'm going to do is add the two exponents. Negative 12 plus negative 5 gives me a total of negative 17. My number already is in appropriate scientific notation form because 4.2 is a number between 1 and 10. Now it's your turn. Everyone try 2.1 times 10 to the 3rd times 4.01 times 10 to the 11th. We're going to pause the video now so that you can have time to get this done. Did you get 8.421 times 10 to the 14th? If you did, great job. If not, let's discuss. Now let's talk for just a minute about division with scientific notation. Division with scientific notation is even different from multiplication. I have 8 times 10 to the 5th power divided by 2 times 10 to the second power. I've actually taken the time to write out what this means. I have an 8 and 5 tens, all being multiplied together. In the denominator, I have a 2 and 2 tens being multiplied together. Remember what happens when we have a 10 over 10. These numbers are going to reduce to 1 and basically be out of our way. I'm only left with 3 tens on top, which is going to give me 10 to the third power. The last thing I need to do is take this 8 over 2, and instead of just simplifying a fraction, we're going to do the division. So in my problem, I'm going to do 8 divided by 2, which is going to give me 4. So now my answer will be 4 times 10 to the third power. So again, we're dividing our coefficients, and in this case, we're going to be subtracting exponents. Let's try. I have 2.34 times 10 to the 6th divided by 7.8 times 10 to the 8th. My first step is to divide coefficients. 2.34 divided by 7.8 gives me 0.3. Then I'm going to subtract exponents. My top exponent is 6. My bottom exponent is 8. 6 minus 8 leaves me with -2. So my answer is going to be 0.3 times 10 to the -2 power. Now this is not in proper scientific notation, so we have to do a little bit of adjusting. In this problem, in order to get scientific notation, now I'm going to have to move my decimal to the right to get it so that one non-zero number is in front or to the left of my decimal. When I move my decimal to the right, I subtract from my exponent. -2 minus 1 for the one place I'm moving to the right gives me -3. So my final answer will be 3, or 3.0, times 10 to the -3rd power. This is my final answer. Now we're going to talk basketball. A basketball has a radius of 1.143 times 10 to the first power. A marble has a radius of 5 times 10 to the -1st power, all measured in centimeters. We want to know how many times greater the radius of a basketball is than the radius of a marble. When it asks me how many times, I need to do some division. So that's just what we're going to do. We're going to take 1.143 times 10 to the first, our basketball radius, and divide it by 5 times 10 to the -1st, our marble radius. To do this, remember, we're going to divide our coefficients. 1.143 divided by 5 gives me 0.2286. We also need to subtract our exponents. I have 1 in my numerator minus a -1 in the denominator. The double negative changes to a plus, and 1 plus 1 is 2. So my answer is 0.2286 times 10 to the 2nd power. What do I need to do to this answer to make it proper? We need to move that decimal to the right. When I move my decimal to the right, It becomes 2.286 times 10, because moving a decimal place to the right subtracts from my exponent. Now I'm going to have to the first power. I could leave my answer looking just like this, or since it asks me how many times greater the radius of a basketball is than the radius of a marble, I can actually multiply that out, write it in standard form, and say that my basketball is 22.86 times greater than a marble. Now it's your turn. You try 6.9 times 10 to the negative 7th divided by 4.6 times 10 to the negative 2nd. I'll give you time to work on that. You should have gotten 1.5 times 10 to the negative 5th power. If you did, great job. If not, let's pause and discuss.